There we go. All right, so what we need to bear in mind is, I think I said this on Monday, k and 3 are constants. So if we kind of deal with what we have here, t equals 3 minus k. What we need to figure out, so it's asking where will it have no solution. So we need to go and essentially figure out what our range is of the function that we are working with in order to go and I'm going somewhere with the statement. I just can't remember where I'm going with it. In order to go and figure out where it would have no solution. Okay, so sorry, everything's just lagging today, so we're doing really well. Okay, sorry, I don't know what's happening. We'll get there in the end. Hopefully it's going to start working at some point for me. All right, so we have to go and essentially work with the function that we have here. So the function that we have in this case is the sine 2x plus 30. What we now need to go and do is have a look and see what this function actually means. So if we go and break it down according to each of the manipulations, this 2x over here is a period change, and the plus 30 means that we've gone 30 degrees to the left. What that essentially means in terms of the range of this function is that it still has a maximum at 1 and a minimum at -1. So yes, the period is now much shorter. So in 360 degrees, we get 2 cycles. And yes, it shifted 30 degrees left, but the amplitude has not changed. And so what that means is that the range of this function still remains -1 to +1. I wish I could tell you what was happening here, but hopefully it's going to sort itself out at some point. So the range of this sine function is -1 to 1. And essentially what we want to figure out is, in order for it to have no real solution, the value 3 minus k must fall outside of that range. All right. So outside of that range means less than -1 or greater than +1, outside of what we have. So what we would need to do is we would need to now take our 3 minus k solution, and we'd have to say, okay, it must be less than -1. And we'd have to take our 3 minus k solution and say it must be greater than +1. Sorry, I was just making sure I had my signs right. And then we can go and solve for k. So k, in this case, -k less than -4. So swap the signs because you are dividing by a negative. K greater than 4. On this side, -k minus 2. Again, swap your signs, k less than +2. So you would need to go and essentially have a look at the range of your original function and then figure out where it would fall outside of that. And this is often, particularly with trig functions, I mean any function, but particularly when we do start working with manipulations of your functions or these k values, try and go back to what the actual function is saying. So go back to what the original graph is saying to you and then work from there. So in this case, I had to go back to what the sine function's manipulations was, understand where it has solutions, so what its range is, and then extend past that range in order to get no solutions. I hope that makes sense. If it doesn't, just let me know. But essentially, we're needing to go back to what is the range of the sine 2x plus 30, and then when we move outside of that range, where do we end up? Okay, Lorato, sorry, I just had a moment. Yeah.
Ma'am, Can you hear me, ma'am? Ma'am, what is the reason that we say, is there a reason why for the first one it's k is more than 4 but not equal to 4?
Oh, sorry. No, I just forgot the equal.
Oh, okay.
Alrighty, guys. So, like I said, we're going to have a look at some Euclidean geometry. The ones we're going to look at today are a little different and not more challenging. I don't want to say that. But I have chosen to look at some IEB papers today for the sole purpose of they ask Euclidean geometry a little bit differently in the IEB exams, in that what we had to look at on Monday was sort of your basic questions, whereby, if I just pop back to one of them, okay, that's a bit overwhelming, isn't it? Whereby I give you a nice diagram and I say, okay, find this angle, find this angle, find this angle, each of them worth a nice easy 2 marks. Whereas an IEB paper, this question is a basic question, but it's for 6 marks. I'm not leading you into find this angle and then use it to find this angle and then. I'm basically asking you, I need you to get to E1, do it by yourselves. The reason I like this is because it's also going to help you prepare for those questions where we do, and like those are the more complex questions where we do say to you, here's a diagram, prove it's a cyclic quad, 4-5 marks. If you can start to train your brain to understand where it is you need to go, it really does help with more complex Euclidean geometry questions. All right, so in the diagram below, BGFE are points on the circle, EAG is a diameter, CD is a tangent to the circle B, and CVE is equal to 55 degrees. So remember, when we go and do our Euclidean geometry, we want to use Dr. CPT. Diameter, radius, cyclic quads, parallel lines, tangent. So just remember Dr. CPT when you're writing paper 2. If you can identify these things, that's going to be useful. Remember, guys, we don't give you useless information. So if I'm telling you EAG is the diameter, it's because I want you to use it. If I'm telling you that CD is a tangent, it's because I want you to use it. So if you identify these 5 things, or some of maybe 2 or 3 of these 5 things, it's because I want you to use it. They're there for a reason. Right, so if we just go and sort of identify those important characteristics for ourselves, remember I said to you, you can highlight, you can scribble, you can do what you want. It's your paper. I like to highlight all of my important features, and I've obviously chosen the most aggressive highlighter on the planet, but you know, why not? Go in confident. Can't tell you what's happening right now. Okay. So there's our tangent CD, and then importantly, we have been told that our diameter is EAG. Now, what I also want you to notice, or what I want you to remember, is that we were told that B, G, F, and E are points on a circle, which means that we have the potential of a cyclic quad. So these little pink vertices that I'm highlighting, points on your circumference. And so immediately I can see the cyclic quad BEFG. I can see the angles in the same seg. That's where I'm going. All right. Now, we are looking for the size of angle E1. So again, identify where E1 is for yourself so that you know where you're looking. E1 is this bad boy down here. And immediately, because I have used Dr. CPT and because I have identified these characteristics for myself, I can immediately see that E1 is an angle in the same seg as angle F2. Now, that doesn't necessarily mean that that's going to have to be my methodology, but the likelihood is that it probably is. Okay, and so we need to think carefully about how we're going to go and do this. All right, the other piece of information that we were given is the fact that angle CBE is equal to 55 degrees. And that is this angle over here. Again, take stock, take note of where it is. It is the angle created between your tangent and a chord in your circle. So immediately we should be thinking tan chord theorem. Right, so Morgan's already made a suggestion here for us on the ball and has said that the whole of angle F is equal to 90 degrees because of angles in a semicircle. I completely agree with you. So this over here is 90 degrees. You can label it angle F, that's fine. If you want to go EFG, that's fine, whatever you want. But angle F is equal to 90 degrees. Yo, my handwriting is atrocious today. Right, the next suggestion we have is that, lovely Morgan, CBE, so the 55-degree angle, is equal to angle F1 because of tan chord theorem. So remember, guys, tan chord theorem, I struggle to verbalize this theorem, and I don't know why, but I do. So tan chord theorem is the one whereby we have almost like, I don't know, like I want to say a kite surf, but I know that's not the right word. Anywho, the angle created between your tangent and a chord is equal to the opposite, or the angle in the opposite segment. So what we have here is the 55 degrees equal to angle F1. So F1 is equal to 55, tan chord theorem. And so if F1 is equal to 55 and the whole angle F is equal to 90, we can go and work out what F2 is equal to. So F2 is equal to 35 degrees. Now, this isn't really something that we stress about, but just so that you do know, when you have angles that must add up to 90 degrees, adjacent angles that add up to 90, they are called complementary angles. This isn't really a reason that we stress about or focus on, so don't stress too much. But F2 is equal to 35 degrees. And then if you remember right at the start, we said E1 is an angle in the same segment of my cyclic quad. So if you draw your butterfly or your bow tie, whatever you want to call it, obviously much better than that, this angle down here, F2, is equal to E1. And so therefore angle E1 is equal to 35 degrees, angles in the same seg. Right, so like I said, this is not hard, but it's seeing where you need to go without me really giving you any information. Like I say, 6 marks, so a fair amount of marks. You get marks for your 90 angles in semicircle, 55 tan chord theorem, 35 angles in same seg. Okay, so generous marks because it is a basic question. It's just not a basic question where I'm leading you or scaffolding the question. I'm just saying, go figure it out. I was going to go somewhere with that statement. My brain is just fried today. My grade 9's just were chaos, and so I'm now chaotic, clearly. Right, so guys, like I said, just nice to see that we can get to where we need to be, even if we have to follow multiple steps. So I'll stop there if you want to take a screenshot while I answer Lorato's question, and then we'll have a look at the next one. Yes, Lorato.
Ma'am, so I see they told us that EAG is a diameter. So
yeah,
in the exam, would you advise maybe we also assume that BAF is a diameter?
no,
Or
because
unless
we
they
don't
say,
know where this. Oh, sorry, I just muted myself. Yes, they would either have to say, or we would have to know where the center of the circle is. Right now, I don't know where the center is, so I can't assume that A is the center.
Oh, okay. Thank you, ma'am.
Okay, pleasure. So guys, in terms of that sort of stuff, and it's kind of what Lorato just said, please don't assume. We have to tell you explicitly that something is what it is. So we have to say it's a diameter, we have to say it's a tangent, we have to say it's a cyclic quad, or that the points are on the circumference in order for you to then know it's a cyclic quad. We would need to tell you, or you would need to prove it. Okay. Right, let's have a look at the next one. So I really liked this question. Potentially not everyone's going to agree, but that's okay. We're people. We can disagree about things. In the diagram below, E, F, G, and D lie on the circle with center C. So in this case, I've told you where the center is. So that means any line drawn from the center to the circumference is a radius. I would need to tell you if you have a diameter, but we can then see radii. Lines ED and GD are extended to H and J respectively. HB and JB are drawn with HBJ equals 100 degrees. FCE is 50 degrees and FGC is 35 degrees. And we are being asked to prove that DHBJ is a cyclic quad. So once again, we go to Dr. CPT and we just identify those 5 characteristics if they exist first. Right, now importantly, E, F, G, and D lie on the circle, which means that E, F, G, D is a cyclic quad. All vertices on the circumference of your circle. Right, so we have a cyclic quad. Next thing we were told is the fact that the center of my circle is at C. So C, which means that any line drawn from the center of my circle to the circumference is a radius. So we know CE, CF, and CG are all radii, which technically means that we know they're all equal in length. We were then told that lines are extended. Now, this is important because what this is saying to me, so it's saying ED is extended to H, for example. What this tells me is that this whole line EDH is a continuous straight line, right? I don't have to stress about, is there maybe just a slight kink in my straight line, creating not a perfectly straight line or 180 degree angle. It's a straight line. So that is true of this EDH as well as GDJ. They are straight lines, perfectly straight. We're then given 2 angle sizes, the first being HBJ, which HBJ is this 100 degrees over here. Now, immediately I should be thinking that's outside of my circle. It's also part of the cyclic quad I'm wanting to prove as a cyclic, or part of the quadrilateral I'm wanting to prove as cyclic. I was also told that FCE is equal to 50, so this angle over here at the center. And the fact that FGC is equal to 35 degrees. So I'm given a whole bunch of information, and I have been asked to prove that something is a cyclic quad. Now, grade 12s, please remember that there are 3 ways to prove a cyclic quad. Option 1 is to prove that your opposite interior angles are supplementary, so they add up to 180 degrees. Option 2 is to prove that the exterior angle is equal to the opposite interior angle. And option 3 is to prove that your angles in the same seg are equal. Just trying to highlight here. So those are your 3 options. Now, if we look at the quadrilateral that we're trying to prove is cyclic, it's this green one that I've highlighted down there. And when we are trying to decide where to even start, think first about what you have, okay? So what I mean by that is we already know one of the interior angles of this quadrilateral, angle B, 100 degrees. We don't have any like bow tie shapes in this green quadrilateral, so I'm probably not going to be able to use converse angles in same seg. I'm most likely going to either use exterior angle of cyclic quad, or the converse of, or interior opposite angles of supplementary. Those will be one of the 2 ways I'm going to prove it's a cyclic quad. And in this case, you can actually do both in order to prove it's a cyclic quad. I'll chat about it as we get there. When in doubt, grade 12, so again, this is a 6 marker. If you really don't know where to start, just start finding angles. So in the circle that you have FGDE, use the angle 50 and the angle 35 and just start working out angles for yourself. If you really don't know where to start, if you know where to start and you know what you're doing, awesome, that's great. But if you don't, just start working things out. Everything should fall into place as you go along. All right, so how is my brain just such a brain fart today? Okay, sorry, I'm getting there. First things first, I'm going to kind of work backwards with you, and then hopefully we'll see where we need to be. So in my mind, I know that I'm either going to have to prove that the exterior angles are equal or that the opposite interior angles are supplementary. So either I somehow need to get that D3 is equal to 80, or I need to get that, let's just get this right, D4 is equal to 100 to prove the exterior angle situation. So I know that this point at D is quite important. I'm going to have to find some angles over here in order to get to what I need to get to. So now I move back and I say, okay, cool. How is this going to work? Can I go and determine anything at D? So the first thing I want you to notice is that D1 and this angle GCE is an angle at the center and an angle at the circumference. Why? Well, because if we go and have a look here, here is the arc of my circle GFE, and that subtends the angle at the center ECG. It also subtends an angle at the circumference D1. So if I can work out what this angle GCE is, I know that D1 is half that angle. And then immediately I have D1 and I can start to get to what I need. So we need to look carefully at our diagram in order to get there. Now, if I go and have a look at that angle at the center, I've got part of it. So I've got the 50-degree part of this angle, but I need to figure out what C1 is. If I go and have a look at the triangle FGC is an isosceles triangle because of the radii CF and CG. So I can very easily go work out what C1 is. So I'm going to give you 2 minutes. I want you to tell me what angle C1 is. Dorata, why are you saying 50 minus 35? So just be careful, it's not an exterior angle.
Oh, okay.
And the reason it's not is because do you see that CE isn't a straight line with CG? It's like a slight kink. So it's not an exterior angle. It must be an extension of one side. Okay. I see you're thinking though. Kani?
Ma'am, I said F1 is equal to 35 because of equal angles opposite that rule.
Mm-hmm.
And then
Angles off equal sides?
Yes. Then I said 35 plus 35 equals 70. Then I said 180 minus 70 because of sum of angles in a triangle. And then I got C1 as 110.
Perfect. All right, so guys, because exactly this is an isosceles triangle, F1 must also be equal to 35 because of angles off equal sides. And then we can use sum of angles in a triangle to get C1 is 110. And so what this means is that this whole angle at the center, ECG or GCE, however you want to do it, is equal to 160 degrees. There's no reason for that. It's just math. You add it. Once we know our angle at the center, we can work out our angle at the circumference. So can anyone tell me what angle D1 is equal to? Remember, we're not using the 110. We're using the whole angle of 160 because this whole angle is my angle at the center. Nice. Okay, so it's 80. Angle at center. That whole thing. Such a long reason. So annoying. Okay, so now we know that D1 is equal to 80. Now, this is where you have options. Option 1 is you can say D3 is vertically opposite to D1, so D3 is also equal to 80. And then we can say, okay, well, D3 plus HBJ is equal to 180 degrees. And so therefore DHBJ is a cyclic quad. I can't spell today. You're just going to pretend I can. Because of converse interior angles of cyclic quad. Remember, it's always a converse when we prove. Or your second option is to say, okay, cool. I know that D1 is equal to 80. So that means that D4 is equal to 100 angles on a straight line. And so therefore D4 is equal to HBJ. They both equal 100. And so therefore DHBJ is a cyclic quad. Because converse exterior angles. I will fix that cyclic now. It's a bit dodgy. All right, so there's two options here. The only one we couldn't actually use was angles in same side because I don't have any bow tie shapes in this quadrilateral. And so you could have done either one. Both of them are absolutely fine. You will get full marks for both. Either the interior angles or the exterior angle of your cyclic quad. Right, and it will depend very much on what you see. So I use the vertically opposite reason as well. But if you see the angles on a straight line and you go with exterior angle, that's also absolutely fine. Okay, yeah, geometry, both the beauty and the curse, depends on how you see it, will give you your specific method that you end up working with. There are often times where you guys see things that I never in a million years noticed. And so just because I do it one way doesn't necessarily mean it's the only way to do it. So just bear that in mind. Okay. Sorry, that was a bit dramatic. Alrighty, so I suppose I have to do mark allocations. Hey, I always forget mark allocations. You can take a screenshot, but if you do want the mark allocation, so again, this was a 6 marker. C is 110. Obviously, the F1 is 100. F1 is 35 degrees because of angles opposite equal sides. C1 is 110 sum of angles in a triangle. So let's get rid of that. It should be there. I do apologize. D1 is equal to 80. Angled center equals 2 times angled circumference. The vertically opposite angles, where are we? And it is a cyclic quad because of your reason. Or with your reason, rather. And those are your 6 marks. Right, and like I say, you could have also used exterior angle. That's absolutely fine. Okay, question mark, can I explain a reason of converse interior angles? All right, so guys, whenever we prove a cyclic quad, like I said, there are 3 ways that we can do this. I'm just going to make this a bit smaller so I've got some space. So I'll start with the one you've asked me about. Jeepers creepers. So essentially what this says to me is if I have, no, I don't know why I've made this choice. Let's not draw a circle. So if I have some sort of quadrilateral, whatever it may be, and I am wanting to prove it's cyclic. If I can prove that this angle plus this angle is equal to 180 degrees, I have proven it's a cyclic. Oh my gosh. I'm so sorry. I need to just have a sip of water because Okay, that was wild. I just choked on some air. I do apologize. One of the reasons we work with when we have a cyclic quad is the fact that when you add together, just ignore the fact that that's an arrow, when you add together opposite interior angles, it adds to 180. So if we can show that the sum is equal to 180, we've proven it's a cyclic quad. When it comes to the exterior angle situation, once again, if we can show that the exterior angle is equal to the opposite interior angle, it's a cyclic quad, because we know that's one of the reasons that we use with the cyclic quad. And then the last one is if we can prove that the angles in the same seg are equal. So let's say, for example, I had these two lines drawn in here, and we had our sort of bow tie situation. If you can prove this angle is equal to the other angle in the same seg, then you know it's a cyclic quad, because that is one of your reasons within a cyclic quad. The fact that angles in the same seg are equal to each other. Right, so it's just going back to what reasons we already know we use for cyclic quads, and then proving that the statement we would usually make is actually true. I hope that makes sense. And let me know if it doesn't. Perfect. Chaos has ensued in my life. I do apologize. I'm probably going to choke again, but you can just ignore me if I do. Okay. Right, so let's have a look at this next question. This is a similarity proportion question. This one is unique in the sense that it's not within a circle. Oftentimes these questions are put in a circle and we calculate from there. It doesn't have to be. I just thought this one was quite nice because it isn't. Please just remember, though, that the bulk of your Euclidean geometry is circle geometry. All right. And so realistically, if you hate geometry, you need to be focusing on the circle geometry, because that is the bulk. But obviously, if you like similarity and proportion, it's also, flip side, easy marks. Okay, so in the diagram alongside, because that's English here. In the diagram alongside, CD is parallel to NH. Panic. CD parallel to NH. NH, so the second line that I just drew, intersects the line DE at G. We can see that there. It's just a point of intersection. K is a point on DE with DG equal to GK. Okay, so that has been given to me on my diagram, but I'm just going to highlight for myself. So DG is equal to GK. The second we start being given proportions, lengths, that sort of stuff, we need to be thinking similarity proportion theorem. We were also told that HK is parallel to FE. So these two vertical lines on the side here. I maybe need to highlight, but it's fine. Hopefully we can see. And the last little bit of information we were told is a ratio. CN to CE. So CN to CE is a ratio of 2 parts. So I use X to 5 parts. Now, what that means, grade 12s, is that you actually know the ratio of CN to NE. If this whole length is 5 parts, this therefore means that NE is 3 parts. Right, so particularly with ratios, I like to fill it in on my diagram. I like to see what I'm working with. I'm just going to make this a bit bigger so we can see clearly. And then we can go into answering our questions. So the first one asks, determine the ratio of EK to KG. So once again, let's start by first identifying where these things are. EK to KG. So this whole length over here. Now we've already been given some information about KG. It's equal to DG. We can't really do too much with that just yet. And this is now where we need to think carefully about what information do I have and how is it going to help me. Now, remember when you're going to use your proportion theorem proportion theorem rule, proportion theorem, you need to be working with parallel lines. And we have been given 2 pairs of parallel lines here. So that's just something that we need to bear in mind. Okay. Oh, here goes my brain today. I'm going to start by working in triangle CDE. Sorry, just have to get my labels right. So CDE is this triangle over here. And the reason I'm choosing to work in this triangle to start off with is twofold. A, I have at least, so the side I'm wanting to work out the ratio of is part of one of the sides in this triangle. And B, the ratios I was given is also one of the sides in this triangle. So I have a lot more information in this triangle than I do the small little triangle at the top, DFE. Right, so according to proportion theorem, DG is in proportion to CN and NE is in proportion to GE. So we can set up our okay, you know what I'm trying to say. The English isn't English in today. We can set up our proportions. We can set that up. Okay, so CN, so this length at the bottom here, which we know is 2 parts, which we'll get to now. CN to NE is equal to, so the side opposite CN that's in proportion is DG over, and the side opposite NE, which it's in proportion to, is the whole length GE. And we know that that ratio is 2 is to 3 parts. If you want to put the x's in, that's fine, but we know it is the 2 parts to the 3 parts. Remember your reason, prop theorem, parallel lines, so CD parallel to NG. You can also use line parallel to one side triangle as a reason. I will double check myself, it's just not a reason I ever use. I just use prop theorem, set my parallel lines, move on. Okay, so what we now know is that, importantly, whilst these lengths are not equal, the ratios are, okay? So instead of saying 2x, I'm going to say that DG is 2y. So same ratio, just different lengths. And this whole length G to E is 3y. Okay, now that's important because I know that DG is equal to GK. And if DG equals 2y, then this section over here, GK, is also equal to 2y. It has to be, they're the same thing. And so that therefore means that when I want this ratio of EK over KG, I have got the 2y, which is KG, and EK, because this whole thing represents 3y, must be y. And I can therefore set up my ratio for what I'm looking for. And so therefore, EK over KG is equal to 1/2, or 1/2. All right, so guys, it's really important that we do understand that these are ratios. They are not lengths. We're talking about things being in proportion with each other. And we need to be looking for these overlaps. So one of the things that we're taught that you're taught when you started similarity and proportion to the beginning of the year, at some point in the year, is one of the most important things we need to be mindful of is the overlaps, the segments that overlap with each other in our proportions. And we need to be able to work with them. Okay, so this is only a 3 marker, 3 marks because you set up your prop theorem and your ratio. You've remembered that GK is equal to DG, so it's the 2 parts, and giving you 1/2. Right, so there's a question to repeat the explanation. I'm not going to go through the whole thing, but we're looking at triangle CDE, so this purple triangle I've highlighted. Because CD is parallel to, actually, sorry, let me do this. Okay, so because CD is parallel to NH, we have proportion theorem in this triangle. And so what that means is I can use the proportion I was given, the CN to CE situation, and I can work out what the proportion is of DG to GE. Once I had that, I knew that this whole DG was the 2 parts, this GE was the 3 parts, but I also know that DG is equal to GK. So if this DG is 2 parts, GK must also be equal to 2 parts. And so if GK is 2 of the total 3 parts, that means the remaining is just 1 part, or I've used Y. And so we know we have a ratio 1/2. So let me know if that makes sense. If not, we can go back to the point where it doesn't make sense and I can explain from there. Cool, Lorato?
Ma'am, with these questions, is it possible to answer the question without, maybe let's say, when the way they set up their paper, they don't give us the ratios, the CN to CE equals to 2 to 5. Would it be possible still to answer this question?
No, I'd have to give you the ratio. Because the jeepers creepers, the segments you're working with, the EK and the KG, are not segments between parallel lines. It's sort of like this top segment of one part of your triangle. So I have to give you ratio information in order for you to solve it. Okay, good. Alrighty. So that was the first question here. The second question, and I'm just going to get rid of all of the space because why? The second question is one of these area questions. Now, guys, we love to ask you these area ratio questions. And remember, if I just pop back to our notes from Monday, I made you take a screenshot of the area ratio relationship. So remember, we've got 2 types. We've either got the situation where we have the same perpendicular height, and then we just use the half base times height and we can cancel. Or we have a situation where we have a common angle and we need to use the sine ratio. Okay, I'm going to be honest. My brain, for whatever, I think I've just been lazy if I'm being completely honest. If we're going to have the same perpendicular height, it means that my answer for the ratio of my areas is just the ratio of my bases. Versus if we are going to have, or if we have the common angle, the ratio of my areas is the ratio of your corresponding sides squared. I personally don't remember those last 2. Again, I think it's just because I'm lazy when it comes to the section because I don't like the section. But you could also just remember those 2 facts in order to like check your answer. Not something I remember. I just remember same perpendicular height, half base times height, common angle, sine rule. It's not sine rule, area rule. So if we go back to our little diagram here and we go and have a look, we are looking at the area of triangle DGH. So DGH, this purple triangle over here, and area of triangle DEF. So DEF, there it is. Okay. Now, what you need to notice here is the fact that these triangles do not have the same perpendicular height. The same perpendicular height would be from F at a 90-degree angle. That's not the same perpendicular height. That's not consistent for triangle DHG. But what they do share is a common angle at D. Okay, so both of these triangles have a common angle at D, which means that I'm going to have to use my area rule. Kirsten, before I carry on.
Hi, ma'am. I just wanted to ask for the, for me, like when I am busy with pictures and stuff, it sometimes gets really busy and like the lines and the colors like drawing on top of each other. So do you have any advice on like, if let's say there's a second question and then it gets too busy, like do you have any advice on how to then look at the picture and be able to see the angles?
Okay, so I'm a bit of a princess when it comes to this. I also have a quite obsession with stationery. So for me, and obviously this is potentially not a feasible solution, but I'll give you what I do, and then we'll think of some more feasible solutions. So like you have those erasable pens, you get erasable highlighters. Okay, so like I say, guys, I'm fully aware of the fact that I have a problem. I've accepted it, it's okay. So I have a whole bunch of erasable highlighters that I use, so that when I do get overwhelmed, I can just erase everything that I've already done and get rid of it. So I know some of you use the erasable pens. Maybe work with those so you can scratch off what you've already done and then it's not overwhelming. My other sort of suggestion to you would be highlight things but in pencil so that you can erase it. So I agree with you. Some of the stuff is quite overwhelming. And so potentially it is useful to do everything in pencil and then say, okay, cool, I have dealt with this triangle. Let me get rid of that. I don't need all this purple stuff anymore. I don't need that anymore. I can get rid of all of that, blah, 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 blah. I can get rid of what I don't need, and then I can go back to square one. Okay. Third solution is that maybe you use your diagram for all your sketching and your rough work and stuff, but do another second sketch whereby as you figure things out, you can fill in the important information. So if, for example, this was my second sketch, and remember, you get a question paper and an answer book. They both have the same diagram in it. So maybe in your question paper, do your scribbles, but in your answer booklet, you're filling in the information that's actually useful to you. So my answer book diagram could maybe look like, okay, well, this is 2 parts. This is 3 parts. This I worked out to be 2 parts. This I worked out to be 2 parts. This I worked out to be 1 part. I'm only going to keep the useful information on there for myself. And then when it does come to the triangles, I can then see much clearer what it is I'm actually working with. I don't know if any of that's helpful.
Yes, thank you so much, ma'am. That was very helpful. I also saw that people were saying that maybe I should use colored pencils, which is also a really good solution. And I also saw like people say I could maybe even draw it on the side, which is also pretty helpful. So thank you so much, ma'am.
Exactly. So that's the thing, guys. I mean, you have to decide what is useful to you. So for me personally, I'm a very visual learner. So which is weird because I actually hate geometry. I hated geometry as a section at school, despite being a very visual learner. I like to be able to color and highlight. But as we saw on Monday, this looks like a unicorn had a stomach problem. Okay, it's overwhelming. It's too much. And so I completely understand needing to figure out a way to do it. So I probably wouldn't do all of this in an exam, to be fair. This was just us explaining as we went along. But I do think a fairly decent solution is draw a sketch or draw the diagram. But just please remember you do have 2. So don't redraw something, particularly if it's complicated and particularly where you need accuracy in your diagram. So you have got your question paper diagram and you've got your answer book diagram. Use them in conjunction. I quite like the colored pencil situation because that you can actually like color in the triangles. Highlighters are sometimes a bit aggressive, but you could do a nice little shade of the triangles that you're working with and you can go from there. Suggestion of redraw them. That's also good. You find what works best for you. Those are just some suggestions. Okay. So guys, even like, no, actually, don't worry. I'm just going to get myself sidetracked talking about nonsense. Okay, so we've taken off all of the useless nonsense. Let's go and have a look at what we're actually trying to do. So I'm looking at triangle DEF. So this pink triangle over here. And triangle DHG. Hopefully now we can actually see much clearer the fact that angle D is our common angle. Okay, we can see that this angle at D is common to both of those triangles. And now we know that because we have a common angle, we're going to use the area rule. All right, so we set up our area rule. I want to miss too much information, but that's okay. We'll get there. Right, so I need to know things. I know that I've got my common angle here. So this would be the sine angle D. And remember, these two sides over here are the two adjacent sides to your angle. So I need to know what DG and DH are, as well as DE and DF. Those are the side lengths I need. Now, obviously, I don't know the side lengths, but I can get the proportions because I have got my parallel lines going on there. Okay, so right now, I only have information along the one side of my triangle, along the side DE. I still need to get information along the side. I'm just going to work over here, guys, just so that it is right by the triangle so that you can see what's happening. But I can set up a ratio. So I can say DK to KE. So DK is this side length over here, and KE, this one over here. It's getting a bit overwhelming, so let's just get rid of that. Is equal to, and now use your other set of parallel lines, the HK and the FE. So that's equal to DH over FE. And now we can make our statement of what's happening. So DK, all the way over here, is equal to the 4 parts, 2y and 2y. Where am I? KE is this little segment down here, and that's 1 part. So 4 over 1. So this is 4 parts. This is 1 part. I'm now using z's because, again, they're not the same length. They're just in proportion with each other. And now I can go and work with my area rule. So if we do the area of the top triangle, this purple triangle DGH, it would be half times 2y times 4z. And you'll see that the variables will be gotten rid of in a second, times sine of the angle D, all over. Okay, apparently we want an arrow now because that makes all the sense in the world. All over half. Now we're looking at the pink triangle. So the whole length here is 5y. And the whole length on the other side is 5z times sine of angle D. And what we see is the sine D's cancel out, the halves cancel out, and all you're actually left with are your bases. So 2y times 4z, actually, let's make our lives easier. The y's cancel, the z's cancel. So 2 times 4 is 8. 5 times 5, 25. And we get our area ratio. Right, so I'm just going to make this smaller so you can see everything. Now remember, guys, these area ratio questions are complex questions. They're not supposed to be super easy. I did find this one a little bit more easier than some of the others, but I also think it's because I just understand it better now that I've practiced it more, if I'm being honest. Like I said, I don't like similarity and proportion. I enjoy the circle geometry. I don't enjoy this. This is not my vibe. But once I practice it and once I understand what I'm doing, life becomes a whole lot easier. Alrighty. Are you ready for the next one? Okay. I'm going to take the sun. It says yes. Great. Why have I all of a sudden got so much space here? Sorry. Never mind. I'm just a bit silly. Okay, there we go. Right, so if we look at this question, in the diagram below, H, E, N, and G lie on the circle with center O. NC is a tangent at N and passes through P. B lies on HC with GB parallel to NC. HP and GB intersect at E. HG is equal to HE and GON is equal to 2x. So I also struggle with geometry because there's so much information here and it sounds like a lot of random nonsense when you like actually say it out loud. Like listening to myself say all of that, I was just like, I mean, that seems stupid, but all right. So this is where Dr. CPT is actually particularly useful. So H, E, N, and G are on your circle circumference. So what that means is this is a cyclic quad. Let's do this a bit better. We also then know where the center of your circle is, which again, like I said earlier, is useful. You can identify radii from that point. We can't necessarily identify a diameter. I would need to tell you that a line is a diameter, but I at least know where the center is. So again, I can identify radii. I can potentially have an angle at the center, angle at the circumference situation. It gives me a few theorems that I can then work with. Why don't you want to be a straight line for me? I'm not asking a lot. There we go. Right. There's the center of my circle at O. Obviously, I've been told that that angle is 2x, but that's fine. The other piece of information I was told is that I have a tangent. So NC is a tangent at N. So at N means that that is the point of contact passing through point P. So basically NPC is the whole tangent that I have there. Okay, hello. Okay, whatever. NC, so my tangent line, is actually parallel to the line GEB. All right, so tangent is parallel to a line there. And I was also told that HE is equal to HG. So HG equals HE. So I actually have an isosceles triangle. Right. So again, a lot of stuff going on, but that's okay. We'll be fine. First question says, prove that GN is equal to NE. So let's just find that and see what we're talking about. So GN, which is this line over here, is equal to NE. So this line over here. Now, guys, the way for us to prove that line segments, i.e. chords in a circle, are equal to each other are to show that the angles opposite them are equal. So if I can prove that G1 is equal to E2, then I've got sides opposite equal angles, and so they would be equal. All right, so this is 6 marks. I'm going to give you 6 minutes. Try. See what you can get, and then we'll go from there. All right, if you've got questions, just ask, but give this a try. Like I said, I've kind of told you what you need to do, so see if you can try and get G1 and E2 as angles. And remember, you were given, I don't know what's happening with my mouse. Remember, you were given the fact that this angle GON is equal to 2x. So you will work in terms of x in this question. MathsLive?
Hello, ma'am. After I discover that, okay, like if I say E2 is equal to X because of angle at center, and then M3 like is equal to X because of alternate angle, and so would G1, I don't know, would G1 be X because of tan? Oh,
Yeah,
okay.
because of tan chord. Exactly.
Okay, thank you.
Okay. So MathsLive's basically spoken us through this whole thing, guys. So firstly, yes, E2 is equal to X because angle center, that whole thing. All right, so this angle here is equal to X. Then we have alternate angles. So we've got the zigzag, which means N3 is also equal to X. And then finally, because of our tangent NPC, we have tan chord theorem, which means G1 is also equal to X. And so therefore G1 is equal to E2. And so therefore Gn has to be equal to Ne because of sides opposite equal angles. Okay, so guys, particularly when you have questions that are like proof questions like this, it is quite helpful to kind of know where you need to be. And this is why knowing your theorems is really important. We need to know, how can we prove that chords are equal in a circle? Well, we have to prove that the angles opposite them are equal. And so it gives us kind of like a very vague roadmap of what we need to be doing. I knew I had to prove those two angles equal. And so I can kind of focus my thoughts on how do I get to that point. Okay, very nicely done. The next question says, prove that GON is similar to GHE. So we're proving similar triangles. This was not a particularly nice question, if I remember correctly. I think maybe it is worth us taking off some of these scribbles. I'm going to leave the X's on for now, because that will probably be useful to us just in terms of when we prove similar triangles, we have to prove angles are the same. So we want to prove GON. So this triangle over here is similar to GHE, which I will highlight for us now. Okay, now remember, to prove similar triangles, there's two ways to do that. Either you have to prove that all three corresponding angles are the same size, so angle, 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 or you have to show that your side lengths are in proportion. Now, we're not going to be able to use sides in proportion here because I don't have any information about the sides. I'm likely going to have to use my angles. All right, so like I said, not a hugely nice question, just because of the fact that realistically, the only angle I actually have that is a full angle in any of my triangles is this angle here at the origin, so 2x. So I'm going to have to start once again finding some angles. And again, because I know my triangles, I can focus that. Now we know that this HENG is a cyclic quad because all four vertices are on the circumference. Now in this triangle GEN, I can easily go work out this angle GNE because I've got sum of angles in a triangle. So GNE, oh, terrible, but anyways, would be equal to 180 minus 2x, because remember G1 and E2 are both x, so it'd be minus 2x. And that's useful to me because of the fact that it's a cyclic quad. I can go and work out the size of the angle opposite. So I can go and say that therefore H2 is equal to 2x because of op angles of a cyclic quad. And so immediately what I have in terms of trying to prove angle, 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 immediately I have got one pair of angles equal to each other. So I now know that H2 is equal to GON. That's one angle pair that I know in my two triangles I'm trying to prove similar. Sorry, I don't know, my brain has just decided to stop working for a second, which seems to be the norm at the moment. All I need is one other angle pair, because remember, if you've got two of your three angles equal to each other, the third angle is automatically the same because of angles in a triangle. So I now need another angle pair. So in terms of angle pair, what I mean by that is I need E1 and this whole angle here, HGE, to either be equal to N1 or this whole angle OGN. So I need to find another angle pair going on here. Now remember, excuse me, we know that these are radii, OG and ON, which means that the angles opposite them are equal. So OGN is equal to angle N1. So this angle, just put a little star there, and this whole angle are equal to each other. And because we know that the third angle in that triangle is 2x, we can go and work out what each of those angles are. So therefore, OG and N1 would be equal to 180 minus 2x divided by 2 because they're equal to each other. So each of those angles are equal to 90 minus x. So this angle, 90 minus x, and this whole angle, G1 plus G2, 90 minus x. So at least I've got two angles that I'm working with here that are helpful to me. Now remember, once again, we already know that H2 is equal to 2x. So I can actually do exactly the same thing in my pink triangle. I was told that HG is equal to HE, so that means the angles opposite them are equal. I'm just going to go on the side here so that we can still see everything. So that means HGE, so angle G2 and G3, is equal to angle E1, angles of equal sides. And so therefore, HGE, which is equal to angle E1, would be equal to 180 minus the 2x of H2 divided by 2. And so we get that both of these angles are also equal to 90 minus x. And so what we've got is the same angles equal in our two similar triangles. And so we have essentially proven similarity. Obviously, we'll write it out nicely now. So now we state in which triangle. So in triangle GON and triangle GHE, we now write down our statement. So we know that angle GON is equal to angle H2 because they're both equal to 2x because I've proven that. We also know that angle, doesn't really matter which one we use, N1 is equal to angle E1 because they're both equal to 90 minus x because I've proven that.
Yeah.
And then we have our third angle, which you could just use sum of angles in a triangle, or you could say that angle OGN is equal to angle HGE because, again, we've proven that it's equal to 90 minus x. And so we have all three corresponding angles the same. And so therefore, these triangles have to be similar to each other. All right, so again, grade 12s, we had to do a bit of working out. We didn't have enough information about our angles to go and prove similarity. So I had to go and work out the angles in each of these triangles I was trying to prove similar, so that I could then say which angles were corresponding, which angles were the same size in order to get the similarity. Right, and here it was very, very much about the fact that you were working with two isosceles triangles, and you could then go and prove those base angles were equal to each other. So like I say, not a particularly nice question because there was a fair amount of working out you needed to do first. But once you had information about your angles, you could then easily prove similarity. Okay, so I'm just going to do that for you to take a screenshot. Rato?
Ma'am, do you mind showing the mark allocations?
Sure. This was question 8. Sorry. So for the first one, that was 6 marks. Okay, so the first one, which was 6 marks, it was getting angle E2, angle N3, your tan chord theorem, and then therefore saying that they are equal to each other with your reason. That's 5 marks. This was 6, so you would likely get, so generally speaking, what we do is senior reasons often will get a mark for statement and reason. You've got angled center and you've got tan chord theorem. Tan chord theorem is the more recent one, and so you'd probably get a second mark there. So they're your 6 marks. Well, the second one, this is just gross. You would get your angle H2 with your opposite angles in a cyclic quad. Reason, sorry. Obviously, you also need G and E. Sorry, I forgot that I had that first step there. You would then get your angles in a triangle, the 90 minus x situation, and then proving the E1 equals HGE, and then getting the similar triangle statement. So you're not actually going to get a mark for any of these statements over here, and that's only because you had to do all the proving over here, and that's where you're going to get your marks in terms of your proof of the sizes of those angles. All right, so guys, just remember again, similarity, only 2 ways to prove. Angle, 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 or sides in proportion. Right, guys, there's like, okay, never mind, sorry. Leila?
Hi, ma'am.
Hi.
Ma'am, this is gonna kind of sound like a dumb question, but in school with us, they were telling us about, they were like being so strict, saying that we shouldn't, no matter what we do, we shouldn't do anything in pencil, because when they mark the final, they don't mark anything in pencil, like they completely ignore it. So, like, what happens if we don't finish and we just end up leaving half of it in pencil?
As far as I know, I mean, that's just, so we will mark the pencil, but as far as I know, the ruling is that if you then want a remark, none of the marking that was done where you answered in pencil will be disputed. So if, let's say, for example, that you accidentally, or no, sorry, that your marker actually, English, your marker marked something wrong that was actually correct, but you had written it in pencil, that mark can't be disputed, because we can't then go and say that someone else within the marking center or a check or whatever didn't erase it and put the right answer. So you can't then dispute what's been written in pencil. But as far as I know, we will mark what's in pencil. You just can't dispute the mark afterwards.
Okay, thank you, ma'am.
Pleasure.
Ma'am, but
'Cause,
preferably, should we write in pencil or pen?
you should write in pen. The instructions tell you to write in pen. I mean, I have kids who will write an entire exam in pencil. Like I say, all it means is you just can't dispute the mark.
Okay, thank you, ma'am.
But yeah, you are supposed to write in pen, yes. Kani?
Ma'am, can you help me with the question? It's a paper 1 question.
Okay, sure. Just give me a second.
Can I see
So
my
guys,
screen?
I'm just gonna wait here for you guys to take the screenshot, and then if you do have any questions that you'd like to ask before you leave for good, that's absolutely fine. You can stay on. If you want to stay and just listen to the questions, that's absolutely fine. If you want to leave because you've got other things to do, that's absolutely fine. Like I say, I'm gonna stay for like 15 minutes, answer questions, and then we'll wrap up. All right, so yes, Kani, you can share your screen. I think everyone's probably got a screenshot by now.
Ma'am, can you see it?
I can. I don't like it, but I can see it, yes. Okay, let's see what we have going on here. I feel like this is most things in maths. We can look at it, we can see it, but I don't want to deal with it. All right, I can no longer see it, Kani, sorry. Is Kani left? No, there we go. Sorry, can you just show it one more time so I can be a more useful person, and then just screenshot it. Okay, we're just going to pretend you don't see the weird stuff over here, but I'll rewrite it now. All right, thank you. Got it? Okay. What was the question actually asking you to do?
Let me check quickly, ma'am. We're supposed to find the sum of x or something like that.
Okay, I kind of need to know what it's asking me.
Let me try and find it again.
I would assume the value of x, but see if you can find it for me.
I might only have the memo, but the memo has the value of x. So
the memo says x equals.
Yes.
Okay, so yeah, I would assume it's asking for the value of x. All right, this seems like a wild time. Okay. 7, 8, 9, 10, 11, 12. All right. So looking at this, sorry. Yes, Kirsten, the recordings will be posted. It's usually next day, so they will be posted, yes. So if you do need to leave it, but you want to come back, that's absolutely fine. All right, so guys, sigma questions, particularly when there's like multiple sigmas, break it down for yourself. So I'm going to start with this first sigma situation. The first thing that you always do is you go and determine your first 3 terms. So to determine your first 3 terms, you take this value over here. That will be the first term that you add in your sequence, and you substitute it in. So term 1 here is 2x plus 3 times 1, which is just 3. Term 2 is 2x times 3 plus 2, which is 3 times 2, sorry, which is 6. And term 3 is equal to 2x plus 3 times 3, which is 9. So those are the 3 terms. And I'm only going to go up to 3 because this number at the top tells me how many or what term to add up to. I'm adding from term 1 to term 3. So I've got my 3 terms. Then I move on to my next sigma situation. So my next sigma situation is this geometric one over here. And I do exactly the same thing. Now, bear in mind for this one, you're starting to add from term 7. Sorry. Okay, here we go. All right, so we do the same thing, but now we're starting from 7. So term 7 would be equal to 3 times 2 to the power 7 minus 1, which will give us something. Which is 192. Term 8 would be 3 times 2 to the power 8 minus 1, which is 384. And then the third term that we add is term 9, which is obviously just substitute in 9. Now, obviously, if you wanted to, you could just keep substituting all the way up to 12, but we do have a formula that we can use, so there's no reason to do that. Right, so what I would now do is, because I've got no unknowns in this situation, I would go and work out the sum. So this is a geometric sequence. So the sum of n is equal to a times r to the power n minus 1 over r minus 1. Sorry, I just had to remember my formula there. Now, what we need to be careful of is the fact that my a value, maybe let's not use that color. So my a value, remember, is the first term you add. The first term that I'm adding is 192. So that is my a value over here. The r value, I mean, you can go and work out if you're not like super confident, but you do have r, it's the base. But otherwise, you just take term 8 and you divide it by term 7. It's 2. And then the other thing just to be mindful of is this n. So remember, the little formula for n is top minus bottom plus 1. You could also count. I'll show you that in a second. So you would take your top number 12 minus your bottom number 7 plus 1. So that gives you 6 terms that you're adding. Alternatively, count. You're adding terms 7, 8, 9, 10, 11, 12. 6 terms. All right. So we have now everything that we need to go and substitute into this formula to get our sum. So that's what I'm going to do. A was 192. R is 2 to the power 6 minus 1. All over 2 minus 1. So 192. And that gives me 12,096. Okay, so what this means is that when I take all of these blue terms and I add 12,096, I must get 0. So what you'll do now is you'll set up an equation. So let's simplify our lives here. If we add these 3 terms here, it's an absolute pleasure, Kirsten. I wish you all the best. You've got this. Have faith in yourself. And truly, I wish you nothing but the best for your future. Obviously, all of you. But yeah, good luck. Okay, guys, so what we do is we add all of these together. 2x plus 2x plus 2x is 6x. 9 plus 6 plus 3 is 18. Plus the 12,096 equals 0. And then we go and solve. So 6x is equal to something. Negative 12,114. And so when we divide by x, that is equal to negative 2,019. I really hope that's right. But that's how I would do it. Just break it down when it comes to Sigma questions. Kani, you can tell me if I'm right or not.
It's right, ma'am. Thank you.
All right. I always panic when I get questions like this because honestly, most of the time I'm just like, I know what I need to do. Let's just try and see what happens. Okay, so Sigma questions in particular, break it down and then combine it all back together. Because like logically, once we have all of these individual parts, it's actually so much easier. But that initial question just looks like, no, I don't want to do that. Okay. Oh, so sorry. I didn't see that there was a question. Oh, Kirsten, are you still here? Have you left us? Left. Okay, so the question was, how many sigma questions do you generally get in an exam? 1. Okay, we're not going to ask you multiple sigma questions. It is generally considered the complex question. Please explain the last part. So I'm not too sure what you mean last part. Do you mean this part over here? Like the solving of the equation? Okay, cool. So I'm going back to what I was initially given. So this situation over here, it told me to take the sum of these x terms. So this situation, which is 6x plus 18, it told me to add it to the sum of this geometric. And the sum of the geometric was the 12,096, which I substituted in. And then I just set up an equation to solve because it told me that it must be equal to 0. So I filled in all of the values that I had found, and I then just went and solved my equation using inverse operations. Does that make a bit more sense? This is simple. So if it's also, just let me know. Sorry, those too many syllables in my mouth. So Sipo, to be fair, I probably would have looked at this a couple of years ago and also skipped it, if that makes you feel better. But just know that it is very much answerable once you break it down. How did I get, 6x plus 18. Okay, cool. So what I did was, so the 6x plus 18 comes from adding term 1, term 2, term 3. So it would be saying 2x plus 3 plus 2x plus 6 plus 2x plus 9. It was just all my like terms. So 2x plus 2x plus 2x is 6x. 3 plus 6 is 9, plus 9, 18. So it was just me adding term 1, term 2, and term 3 from my linear sequence. Pleasure. Barato?
Ma'am, I have quite a few questions with paper 2. So my first one is, how often will they ask us about the radius perpendicular to tangent, like that theorem?
I mean, like, I can't really tell you how often, but it's not really one that pops up a lot. So maybe once or twice, but it's very rare that we ever actually use that theorem. So it won't come up a lot of times, if it does.
But it's good to know.
Yeah, definitely.
Okay. And then what about congruency? Because I know usually it's about similarity and the proportionality.
Yeah. So congruency only really comes into some of your theorem proofs.
Oh, okay, ma'am. And then, ma'am, I posted a question from my prelims question paper, and I was wondering if you could help me with like the 2.
Oh, there we go. Okay, so I can help you. However, I do need to know what the questions before this were. What angles had you found?
Oh, okay. So the angles 7.3.1 was angle D2, and then there was 7.3.2, which was angle
D2,
which was angle A,
yeah.
and then there was 7.3.3, which is angle B. Those all those 3 members out of like 2 marks.
Yeah, okay. No, that's fine. Okay, so we were given that C2 is 20, and we were given that O1 is 80. And then you had to find these other ones. So I'm hopefully going to do those quickly. So D2, she said with so much confidence, D2 is equal to 40. angled center 2 times angled circumference, because there's your angle at the center. On the same chord, there's the angled circumference equal to half. So that was 40. Angle A was equal to something. Angle A, I would probably say O2 was equal to 100. And then again, I would use angled center, angled circumference. So angle A was 50. And then angle B, angles in same seg with A. So that's 50. All right. So now we want D1. So we want this angle D1. Centers O and M, common tangent. Kani?
Can I say something I see? I don't know if it's right though. Can't you say OB is equal to OC because of the radii? And then you can say angle B is equal to angle C because of equal angle. I keep forgetting it, but that
So, angles opposite equal sides.
Yes, ma'am. Then you say 50 minus 20 to get C1. And then you can say you can say D1 is equal to C1.
Because
of angles in the same segment.
Nice. Okay, you got there before me. Nice. Okay, so exactly. These green lines, radii, which means this whole angle is equal to that whole angle. So if these are both equal to 50, that therefore means that C1 must be equal to 30. And C1, and if you look at your sort of bow tie here, C1 and D1 are angles in the same seg. So D1 equals 30, angles in same seg. Right, okay, so we have this as 30 degrees now. And then angle Q is this angle over here. Okay, so we know that M is the center. We weren't told that GQ is a diameter, although it does look like a diameter, but we don't want to assume. It probably is going to have to use a diameter. Okay, well, we know that D3, because of tan chord theorem, here's your tangent, is equal to 50, which means that D7 is equal to 60 because of angles on a straight line, and that therefore means that D4 is also equal to 60 because they're vertically opposite. Let me just take off this little scribble here so we can see that. Look at that. So D4 and D7 are vertically opposite to each other. And so that therefore means that, again, tan chord theorem, Q is equal to 60 degrees. I hope you got all of that. I suppose I should write all of that down here. Right, so D3 equals 50 tan chord. So D7 equals 60 angles on a straight line. D4 also equals 60 because of vert op angles. That's not how you spell vert, is it? Vert op angles equal. And so Q is equal to 60 tan chord. Woo! Okay, so the right all makes sense? Could we have also said D5 equals D1?
Thank you.
Pleasure. Yeah, we definitely could have also used the D5, D1. Those are also vertically opposite. I was just, so, Rato, I'd be interested to know what they did on the memo, because if we did find D5, we would have to figure out what angle N is. And I would be interested to know if they said that that was 90 because of angles in the semicircle, even though we don't know if that's the diameter. Because that would then be 730. That's 120. So it does actually work out, yeah.
Ma'am, can I quickly check for you?
Yeah, please. I'll be interested.
Okay.
Honey?
Ma'am, so in geometry, if we given like it says in our given information like a center, and then like they say O is the center and they have a line passing through it, and they didn't say it's the diameter, are we not allowed to say like use the diameter in like our proving?
So the reason no is because technically if I've got a circle, that's not a circle, is it? Let's try that again. So if I've got a circle and I tell you this is the center, I don't know if this line kind of kinks up a little bit. I have to know that it's a straight line through my center.
Okay, thank you, ma'am.
And so the thing is, usually they will say to you, BOD is a diameter, or BODMQ, whatever, is a continuous straight line. So then you know it's a straight line. But technically, yeah, they should, because you don't actually then know if it does kink or not. Kink probably isn't the right mathematical word, but yeah. Rato?
So, ma'am, they said N is equal to 90 degrees angle in a semicircle. And then they used the 180 minus 90 minus 30 equals to 60.
Yeah, I mean, we really shouldn't assume, and I mean, unless like it's clear it's a straight line, unless somewhere it says it's a straight line, we shouldn't assume it. Leila?
No, ma'am, I was gonna ask about what you said now, because they never say it was a straight line. So can you just assume it?
Well, that's the
So
thing.
if
Like
we've done that,
they should say it's a straight line. You can't technically assume it. So I would be interested to know what the argument was from some, because I mean, I would have argued that if I'm being completely honest.
ma'am, so since they didn't say that and you did this way, you'd still get the marks for it because you didn't get to the answer, right? Okay,
Yeah.
thank you.
So I don't know where I was going with that statement. There's often different ways to do the same thing, so you'll still get full marks, yeah. Any other questions, grade 12s? Any tips for paper 2? Okay, so start where you're comfortable. Because you get an answer booklet in paper 2, start where you're comfortable. So if you are more comfortable with trigonometry than anywhere else, start with trig. Make sure that you know your analytical and statistics, or analytical geometry and statistics, because that is where you need to be banking marks. You need to make sure you're getting like 80-90% for those sections, so that if you do have a bit of an oopsie when it comes to trig and Euclidean, it's not the end of the world. And then in terms of trig, I don't know how to put this into words. You have all of the information that you need. So some of the questions do look incredibly overwhelming, but kind of like what I was saying with the sigma question, break everything down. So when you have a trig question that's, okay, sorry, we had a whole bunch going on here. Yeah. So when you have a trig question that's, this was a terrible example. Jeez Louise. That looks a bit gross, that there's a lot going on. When you have an identity, there's a lot happening. Don't panic. just go back to your basics. Go back to what it is that you know. Go back to your double angles. Go back to your compound angles. Look out for those things. And remember that obviously it's grade 12 work, so we're going to test you a fair amount on compound and double angles. When it comes to Euclidean, kind of like what we were already talking about, use your diagrams, use them in the best way that you see fit. And honestly, particularly for Euclidean geometry, if you're really stuck, just start figuring out a bunch of stuff. So just start figuring out angles, start saying what angles are equal to each other, because the likelihood is that something you write down will earn you marks, because of the fact that every bit of information we give you is given to you because we want you to use it. So if you are using information to get values, we have wanted you to do that. So you will likely earn yourself marks in any case. But yeah, I don't know how helpful that is, but that is my advice for paper 2. Paper 1, so paper 1, the sections you need to bank marks in is your algebra, so question 1, because that's all grade 11. Finance, it's substituting into formulas, as well as probability. Okay, now I know not everyone likes probability, but it's a section where you can bank marks. When it comes to functions, so hyperbolas, parabolas, all of that stuff, read your questions carefully. And once again, just think back to the manipulations of your graphs. Think back to what happens when you when A is negative, when you shift left and right, when you move up and down. Just understand your manipulations. Understand how to find an x-intercept, a y-intercept. Know how to work out points of intersection by making your graphs equal to each other. So all of those basics should get you 70% for functions, which is awesome. When it comes to calculus, obviously remember that the whole first question in calculus is derivation. So know how to use your first principles rule, know how to get your formatting correct for your derivatives so that you can find your first derivative using the rules. In terms of optimization level, the words were in my head and now they've fallen out. In terms of optimization, so read your question carefully. It is often a volume surface area situation. And so what you generally need to be doing is you need to set up an equation for both of those things in order to then substitute one into the other. So just read your question carefully, identify what it is that you're trying to work out. Are you trying to minimize the volume? Are you trying to minimize the surface area? And know your formulas for those things. Generally, we do give you formulas for your complex shapes, which are your spheres, your cones, your pyramids, but we don't necessarily label them. So you still need to be able to identify them, so know your formulas. And then, like I say, knowing your differentiation rules. So you don't want an x in the denominator, you don't want any surds, stuff like that. Knowing those rules is also very important for optimization, because often the equations you end up working with are a bit ugly, and getting them into the correct format is useful. But like I say, look out for what it is you're trying to solve and then set up your formulas based on that. If I give you volume, set up an equation using volume. That's what I'm asking you to do. So yeah, optimization, just look out for the information that they've given you and how you can then use that to set up your equation. Any other questions, guys? All right, like I say, I really do wish you like all the luck of the world, not only for these exams, but also just your futures. I know that all of you are going to do big and bright things. And so just know that I'm thinking of you when you write on Friday, and those of you writing paper 2, obviously on Monday, or I think all of you write paper 2 on Monday. So I'm thinking of you. I'm hoping that it goes well for all of you. And remember, if you do have questions between now and Monday, please just pop them on the Google Classroom. I will have a look and put answers up for you if you do have any. But yeah, guys, seriously, wishing you all the best, and you have been an awesome grade this year. I've really enjoyed working with you, and so I really do hope that it all goes well. Okay, but I will send regards to my cats. I will give them loves and cuddles now. Thank you, Awami. I do appreciate that. Yeah, it's going to be interesting marking, but I'm looking forward to it. Hopefully I learned something as well. And yeah, guys, just thank you for being awesome. And you have got this. You've been working really hard. Walk into your papers with confidence. That's the most important thing. Don't let other people freak you out. You just do you on the morning of your exam. Find a quiet place. Sit calmly. You've put in the work. Okay, and not everyone can say that. So you've put in the work. You know what you're doing. Go in with confidence and just back yourself. Okay, because I back you. You need to back yourself as well. But yeah,